Hello, this is the second part of our lecture 15, Principle of Linear Impulse and Momentum. We're in chapter 15, Kinetics of a Particle, Impulse and Momentum. This again, to start with some example or application. You see the baseball player, he is hitting the ball with his bat, and he is applying the force, maybe a short amount of time, so that's force on that amount of time. If you multiply, that's your impulse, and so you're doing impulse on the ball, and then it's getting a different momentum. That was so the ball may be coming in this direction, so it has momentum 1 with a given initial velocity v1. We from the ball we applied impulse force, I don't know, a small amount of time delta t, so now it got obtain a second velocity, final velocity v2. The mass remains the same, m1. So in this scenario, this kind of scenario, if we want to know what is the final velocity of the ball after the batsman hit it with his baseball bat, we can apply this impulse principle of linear impulse and momentum. Again, some example, same thing for the cork and racket ball bat. You hit the cork with the bat and it gets a different momentum. Again, here you have the ball at rest, so the initial mv1 would be 0 in this case, and the football player applies some force into the ball, and it will gain a momentum of v2. So we can find the final velocity from applying the principle of linear impulse and momentum. So it will be principle of linear impulse and momentum. Let me correct here. Linear impulse plus and momentum. So let's have. So we kind of wrote down the principle of linear momentum, impulse and momentum in previous part A, where we had the initial momentum v1 plus the impulse that we talk about, force for a certain amount of time, and the final velocity v2. So this is our principle of linear impulse and momentum, which states that the initial momentum of a particle at time t plus the sum of all the impulse applied to the particle from t1 to t2 is equivalent to the final momentum, which is m1 v2 of the particle at time t2. So let's graphically draw an example. If we have if we're playing a billiard, okay, so the billiard ball, I don't know, it could be number 8 or something. Assume that it is moving slowly in this direction with a very m1 v1, right? So now is that we apply an impulse on that same ball. So let me draw the same color. So now the same ball moving us that direction was applied an impulse force by the stick, which is summation of force time from any short amount of time t1 to t2. So what would be the result? Due to hit with the stick, it will have different direction of motion, So maybe it's moving in this direction with a new velocity v2. So it is the final momentum of the billiard ball. So if we know the initial velocity and if we know the impulse, we can get the final velocity of this system. So now we're gonna further simplify our this principle of momentum, linear momentum, and impulse. So if we break it down in our rectangular coordinates, rectangular coordinates, so we will have for the x direction, so let me draw a rectangular coordinate. It could be x, y, z. So if we segment this equation into all those coordinates, so we'll have m, mass is directionless, vx1, the initial one, plus summation of force in x direction, right? Fx dt, and it will be m summation of velocity vx in x direction of the final one, that is 2. Similarly, we'll have v y1 plus summation of force integration fy dt equals to mv in y direction to the final one. And we will have our z direction, z1, the initial one, summation of the impulse, summation of force in z direction dt equals to m vz to the final one. So in rectangular coordinate, we can segment this equation in x, y, and z coordinate for same way you did it for your statics. You had angular force, you divided into x and y component. Same here, we just divided in x, y, and z coordinate. So now we're gonna expand this principle of linear impulse and momentum for system of particles. So expansion of this principle for system of particles. So we go back to our basic concept. If you have okay, before that, let's define a coordinate system that we just talked about, x, y, and z. And for example, we have a body that has a lot of particles inside. A small particle here, a small particle there, another particle here, another particle here. There is some force acting on the body. It could be F I. So there is like a lot of particles, external force, and the particles. We can also define a center of mass. So we can define it as a z, that point, and the position of the center of mass is defined by r z. And for each of the particles, we also have different position vector, which is ri. And there's also internal force of the particle onto each other, which can be defined as a small fi. Now, this is the system of particles. So when there's a lot of more than one external forces, what do? We take summation of all the forces. It's a summation of all external forces. And here it'll be the summation of each particle So mi, so I represents each of the particles. So if there is a 10,000 particles, so I will be from 0 to 10,000. So we have to take sum of all the particles, and the velocity of each particle. So particle 1, particle 2, particle 10,000. So that's the summation. Now if we do the same thing and taking integration to find the impulse and momentum, if we do follow the same thing that we did for the previous part A lecture, we will have summation of m1 mi for each particles, vi, velocity of each particle initial, that is 1, and the impulse a certain amount of time from t1 to t2, force dt over short time, will be equals to mi. So each of the particle m1, m2, m3, right? So that we're representing that as an I, and the velocity I at the final position. So the final velocity, which is 2. So this is the same way we did m1, v1, m2, v2. This is just the summation of all the particles. We know that inside a body, all the particle exerts the same amount of force to each other. So the internal forces cancel out. So meaning the summation of all internal force Fi would be 0. So we don't have to consider that. We have to only consider the external force F. Now we can define the position r z. So m r z is equal to the summation of m I r I. We can get the center of mass from this equation, where this equation tells you that the summation of all the mass of all the particles multiplied by their position vector from the coordinate system or system origin is equals to the total mass, where m is equals to the summation of all mass of each particle. So m multiplied by the position vector of position rg of the center of the mass. So if we have that, we can write by taking derivative of this equation. If we take derivative of this equation with respect to time, we will get mvg, because m is constant. If we take derivative of rg over dt, which becomes velocity, because r is a position displacement, and derivative taken with respect to time gives you velocity. So we can write from here, by taking derivative with respect to time, mass into vg, the velocity of the center of mass of the body, equals to the summation of mass, which is constant, remains the same, is the velocity of each of the particle. So once we have that, we can rewrite this principle of linear impulse and momentum for the system of particle as mass, total mass of the entire body multiplied by the velocity of the entire body, which is vg, and this is the initial condition at 1 before applying impulse. So that we'll add the impulse t2 t1, which is Fi, external force, all the external force over time t2, and it will be equals to final total body velocity vg, So this is T2 because it's the final one. So this is the equation of our principle of linear impulse and momentum for a system of particles that constitutes a body. So what this equation tells us that if there is a total body that has a lot of particles inside, finally we can take the total mass of the entire body and the velocity of the entire body plus the impulse that was applied is equals to the total mass of the body and then the final velocity of the total body. So we don't have to consider each of the particle that is inside the body. So that was it for today. We're gonna solve some problem in class, and we're gonna move on to the next part of this chapter 15. So suggestions for you to just go over the video, have your textbook with you, and when you watch the video, have your textbook open and try to get the help from this video, and read the book and try to solve some problem, the example problem given on the book, and I will try to provide some examples, and from there you can solve problems you can start solving problems. So till the next session, thank you. Bye.